Just a quick video here, continuing from where I left off in the last video. I had taken one of these dev boards that has a pair of PSoCs on it, really the primary PSoC, and then a small programmer board with a slightly different PSoC on it. And I had taken one of those extra programmers that I had lying around and desoldered the PSoC and placed it onto one of my boards that I designed, just as a little utility / test board. From there, I went and grabbed a programmer, just another one of these that I could plug into my USB on my computer, plug it into this header, and try to program it. And it did not recognize the PSoC. It didn't see it, couldn't communicate with it. You know, in the process, I did put on the capacitors on the back just to make sure there wasn't some issue with missing the capacitors causing the issue. I had some to start, but then I populated the rest of them. That didn't help. So then I took one of the full boards and took the main PSoC off and put it onto a different one of my PCBs. They have the same pin out. It's just a different speed processor essentially in the PSoC. And that also did not work. And so that was not a good feeling when I had two boards, two different PSoCs, and I couldn't even program it. So that's what I was running into. So then I was doing a little bit of digging, and I went through really my schematic. I went through the schematic for the prototype board. I went through the documentation for the PSoCs just to triple check that my schematic and design should work, or as far as I could tell, make sure I didn't miss anything obvious. And that all seemed to check out fine. So it seemed like, okay, the design should have been fine. It should be detecting the PSoC when I plug in my programmer. But then I came across this information about the PSoCs, or really these QFN packages from this company. And I noticed that there's a max temp of 260 degrees Celsius. And I think when I was doing my desoldering, especially the desoldering, not the soldering, because the desoldering was lead-free. So I was pulling off of the original board, and that original board should have had lead-free solder on it. So it has a little bit higher melting temperature. And you can see here on the screen, it shows 217 degrees Celsius approximately for that. I was probably running a bit higher than that. And let's see what I was running. I was running about 600 Fahrenheit, so 315 Celsius. And their limit, they're saying, is not going to support 315. It was 260. So I thought, well, I better go back and see if I can take one of these off, really paying attention to temperature. I turned my hot air station down. But what I actually started with was the hot plate, and I just used the hot plate to completely remove the existing PSoC from one of these little programmers. And I just slowly turned it up. I used an IR gun that I have to measure the temperature just to kind of be careful as I went. And I pulled this off at probably the lowest temperature it would come off, which was great. So it was a controlled remove of the PSoC. And I took the PSoC off of this board that wasn't working, put the new one on it, and used my hot air gun with leaded solder, so not lead-free. So that allowed me to go with a lower temperature, of course, with the hot air gun than I had used the first round, and got this on there. Then I turned around and grabbed my header, and of course I've I've got all the capacitors on the bottom. I've got all the resistors and LEDs for 2 of the ports, or 16 of the bits connected, and then I plugged this in to see if I could program it. And it worked. So it recognized the chip, and I programmed a little test pattern on the output just to see if that would work. And everything mostly worked, but I had a couple LEDs that weren't working quite right, or weren't working, and it just ended up being a solder issue. So I just cleaned up the solder on those pins here on this QFN package, and then I was good to go. So at this point, I have this board. I can take in power on this header. I just got a couple basic capacitors. I got a bunch of capacitors underneath to support the PSoC. I've got my LEDs and my resistors, and I can come in and apply power, which I'm just going to pull off this board for now. And I have just a simple test pattern running. And if instead of that, just simple power, I want to reprogram, you saw the lights just kind of scanning across, I can come in now and just take one of these standard programmers, plug into the header in my circuit, in my board. Let's just say this was my 486 I'm working on, and plug it into USB. Now USB powers it, so right away you see it start running. But I can now go into, let's just say here is a slightly different way to test the LEDs. So right now I'm just going from the low LED to the high, and I'm sweeping across. What you see here in this PSoC creator software is I'm just saying I want a 16-bit counter, and I want to just simply output essentially in binary out to those pins. I can go over and choose which of my pin names goes to which port. So that's 15.7 down to 15.0, and then it's 12.7 down to 12.0. So I just assign those sequentially, and then I can go ahead and program that. And so it's going to do whatever it needs to do to compile and get ready, and then program this. And you can see that programmed very quickly. And now I'm running just simply a binary counter is all I'm doing. So it's just going to work its way up. And I'm running that at 200 Hertz is what I've got this clock set to. If I want to go back to the other test program I had running, I can jump over to a different project I have right here. I couldn't find a component logic-wise in here to just drag out that is a serial in parallel out shift register. So I just quickly put in some digital compares, and I said, okay, put in a 4-bit counter, check for the 15 different values, and turn on one of the pins. There's got to be a better, faster way to do this than what I did. This didn't take long, but I'm just thinking a plain old serial to parallel shift register would have done the job. But I don't think there's one of those components in the drag and drop type components over here. Anyways, that's what I did. So I can come in here now. I can choose what clock speed I want to run. Maybe I want to pick this up and run at 100 Hertz. And I will program this one out. And so essentially all this is doing is it's counting and checking the bits, and then turning on or checking the value essentially, and then turning on the appropriate singular LED. And so now it's down here, it's programmed, and there goes my sweep across, and that's pretty fast. My camera is probably only running at 30 frames per second or 30 Hertz. So that's not going to be real helpful if that's not picking up very well, but maybe I'll drop way down to 5, just make it go real slow. But this seems to validate that I can now take one of these boards, I can pull off the programmer PSoC and reuse it. The pinout on this is identical if I pull off this other PSoC, so I could pull it off if I wanted to. Again, the only difference really is this one's a bit faster as far as the two PSoCs are concerned. But now, if I have some of these kits, I've got two PSoCs I can use, and that is working just fine. So that's good with this. So now what I'm going to do in probably the upcoming week or two, I have the same board, but for a slightly different PSoC. So instead of this small QFN package, I have a larger package that gives me many more I/O pins or GPIO pins. And I'm hoping that I can then use that on my 486 DX2 build for all of the address decode and other signal logic that I need to put into that, which would be great. So I could have a single one of these placed on my PCB. I can have a simple header that I can plug into. And I can also set up with like a JTAG header. And so that's another option. Instead of this style header, I could do a JTAG. And that might be something I could play around with, or put both headers on, however I end up doing it. But that's another option for me here as I move forward, which will be kind of interesting. So next step then will be, can I repeat that on this with a different type of package, a larger package, more I/O pins. And in this case, really I'm just trying to, again, test the output. And I have the same thing. I'll have 16 LEDs and resistors. But the difference between, if I look at these two boards, this one here, you're going to see has additional, you can see here there's 1, 2, 3 ports missing. So that's 24 pins. This smaller one doesn't have, and that this one does. So I got those there that I could use. So 24 additional pins that this slightly larger package will give me. And actually I like that package because all of the capacitors just fit very nicely underneath it because of its size. So if I can get that going, that will be quite nice. So stopping there, maybe I'll come back here in the next week or two with this one running. We'll see if that works out or if I run into any issues with that. And then I can kind of compare my experience of this little QFN versus this larger package here.